What kind of data are LLMs trained on? Picture a giant puzzle made up of billions of tiny pieces. Each piece is a slice of human communication, websites, books, conversations, even lines of computer code. When put together, these pieces form the training ground for large language models. They don't just learn words, they learn the rhythms of dialogue, the logic of technical writing, the storytelling of novels, and the quick-fire style of social media. The variety is staggering, and it's exactly what gives these models their versatility. Though here's a wild twist. If current trends hold, we might exhaust the world's stock of public human-generated text data for training these behemoths as early as 2026 to 2032. So what kinds of data are actually used? Let's break it down. Webpages. A huge chunk comes straight from the internet. That means blogs, articles, forums, basically text on almost every topic you can imagine. And get this, much of it draws from the Common Crawl dataset, which hoofers up 3 to 5 billion web pages every single month. That's 500 times the number of articles on Wikipedia, totaling over 250 billion pages scraped across its 17-year run. Books. Digital libraries add depth with structured storytelling, history, science, and every writing style you can think of. Wikipedia. An essential source for general knowledge, written in a more structured way. Fun fact, every large language model released to date has been trained on Wikipedia content, which often forms the single largest chunk of their training datasets. Conversations. Data from conversations can help models learn dialogue patterns and less formal language styles. Code. Including programming code in the training data has been found to improve models' logical reasoning abilities, not just their coding skills. Technical articles and papers. Scientific papers and technical reports provide models with exposure to specialized language and complex ideas. Q&A data. Pairs of questions and answers can help the model learn to provide direct responses. Social media. User-generated content from social media can offer insights into informal language and current trends. Another critical issue related to data is bias. Training data reflects the biases present in the text it's drawn from. For example, if the word nurse is more often associated with women in the training data, the model might develop a gender bias. This can lead to biased or unfair outputs from the LLM. Addressing data bias involves techniques like balancing categories in the dataset and increasing the diversity of perspectives, including language diversity. As we push the boundaries of what's possible with LLMs, the future of training data is looking less like a treasure hunt through human archives and more like a sci-fi factory of fabricated knowledge. Enter synthetic data. In 2025, it's exploding as one of the most impactful trends, where AI generates its own training material to fill gaps, dodge privacy pitfalls, and even self-correct biases. Imagine LLMs bootstrapping their way to enlightenment without scraping another web page. This isn't just clever engineering, it's a hilarious plot twist in the AI origin story, turning models from passive sponges into active creators. Yet, as we celebrate this ingenuity, it raises a cheeky question. If AI starts writing its own textbooks, who fact-checks the teacher? Ultimately, the power of LLMs lies in this evolving dance between human ingenuity and machine-made data, ensuring AI doesn't just mimic us, but evolves beyond our messiest habits towards a fairer, funnier, and frankly, more fabulous future.